the folks, Alex here. So have you guys ever wondered how the hell stuff like CPU ID works on Linux, right? So if you haven't heard of CPU ID, it's basically just a kind of small userland utility on Linux that somehow would provide you with a bunch of information on your CPU, right? Yeah, and what's interesting about that is that it would never actually consult any third-party data source for that. It would not call into the kernel. It would not, read any data from like online or in local databases or anything like that, right? It would somehow just query the processor itself and learn all these marvelous details from the processor itself. So let's see the output of that, right? So if I just run it like that, you will see that, we've provided with a ton of information, and 99% of that is basically completely unusable by the average Joe. What is kind of usable is that we can at least look up the vendor ID. So now I know that I'm on authenticated AMD. And what else is like brand name for the processor itself, right? So this is like AMD Ryzen 9, blah, blah, blah. So the purpose for today's video would be to just learn how CPU ID works, basically like recreate a very like trivial kind of clone of that CPU ID thingy that would basically just give me the vendor ID and the brand name, and we would try to like run that little script, let's call it, on a bunch of different Rust playgrounds, and we will see what kind of CPUs these guys are using, which I think is kind of interesting. In order to understand how CPU ID actually works, let's go ahead and disassemble it real quick. So obj dump, and long story short, again, it turns out that CPU ID, the utility, revolves around that CPU ID instruction. So there is an instruction called CPU ID on x86 compatible CPUs that allows you to like read all that data from the CPU itself, from the kind of microcode of the CPU and all the fuses and all that kind of stuff, right? So yeah, and you can see that there is a bunch of invocation of that CPU with like different arguments and whatnot. Yeah, let's go ahead and read on CPU ID instruction, right? So CPU ID instruction. So on x86, CPU ID instruction is a processor supplementary instruction allowing software to discover details on the processor. And it was introduced in 1993. And prior to that CPU ID instruction, programmers would write esoteric machine code which exploits minor differences in CPU behavior in order to determine the processor make and model. You might also think like, why would you even need to learn what kind of processor we are running on, like in that kind of great details? And again, for an average Joe, there is no reason for that, but imagine that you are writing something like LLVM backend, right? That is supposed to like produce extremely optimized and native code for that specific machine, right? So how does it know that, for instance, AVX 512 or I don't know, SSE 4.1 or something like that is available? So the only way to learn that you can use those is basically to ask your CPU whether that would be fine or not. So let's maybe do AMD CPU ID manual. We could have pulled up the Intel's manual, but I'm more comfortable with the AMD's one. So CPU ID. So this is CPU ID instruction, right? So it provides information about the processor and its capabilities through a number of different functions. And software should load the number of the CPU ID function to execute into the EAX register before executing the CPU ID instruction. The processor returns information in EAX, EBX, ECX, and EDX registers, right? So again, you basically like put whatever, put a number of a function that you're interested in EAX, and then you call the instruction, right? And the result will be put within those registers, right? EAX, EBX, ECX, EDX. And all the functions are split into kind of, basic functions, like standard functions, right? And the number for these look like that. And also extended functions, which look like that, right? And yeah, so testing for the cpuid instruction. So some processors don't really have that cpuid instruction, right? So the manual would actually, teach you how to like test if that invocation even makes sense. But of course, like any modern x86 compatible CPU, will work just fine. So, and we'll learn that the cpuid instruction actually gives you like a ton of information, and we would only need just the kind of vendor name and the processor name, right? So yeah, so the cpuid's standard function 0 loads the loads the AX with the standard function number supported by the processor implementation, blah blah blah. And by executing this standard function 0 or extended function 8000 these, like either of these, would load the 12-character string into EBX, EDX, and ECX, right? So basically that into those registers. And for instance, for AMD, that would be authentic AMD, right? So it's written like in little Indian manner here, right? So authentic AMD. So let's go ahead and just create that. Cargo new bin. It's not even a CPU ID clone. It's like CPU name res or something like that. Cool. All right, so does it work? Cargo run. Yeah, our Hello World project works. What you are not happy about exactly? Cool. So yeah, so we will be needing a means of running cpuid instruction, right? So use stt arch x86 and then cpuid, right? Of course, like the function that we will be invoking is unsafe, so function entry, and who knows how it's implemented. Yeah, so let's say function entry, right? So let's go ahead and try to read the vendor name, like that thing, using the cpuid. So in order to do that, it says that we will be needing to invoke the cpuid with the standard function number 0, right? And like yeah, so vendor name here would actually be cpuid result, right? Cpuid result is just a struct that holds a bunch of registers outputs, right? And basically it says that if you print ABX, EDX, and ECX, right, and that would be 12 characters total, you're supposed to get the authentic AMD on my machine, which is kind of interesting. So let's vendor name string, something like that. So string with capacity 12, right? So it's mutable. And then, what is it? ABX, ADX, ACX, right? So vendor name string, push string. That would be vendor name. What is it? ABX. 2LE bytes, and from UTF lossy. How about that? And yeah, it's supposed to be, yep. And but you're not happy here. Lossy, how about that? Sure. So EBX, then EDX, ECX, X, right? So let's just go ahead and print line the vendor name string. Cool. And yeah, so in fact, I'm getting the authentic IMD string, right? Using the CPU ID invocation, right? And the other thing I'm interested in is a function from extended list. Let's see. So let's see. Instruction subset of CPU ID features, obtaining processor information via the CPU ID instruction. So let's click here. Yeah, and it basically goes into a lot of details on different functions and such. We basically need to scroll down to the extended list. Extended generation. What is it? This is steel. Extended functions. Yeah, so these are extended. Cool. So yeah, so that one, right? So function 8002, right? Extended processor name string, right? So basically, I would really love to get the CPU ID thingy, right? But it's like, I would really love to get that string from the processor. And I believe the way to do that is by invoking that function, right? So basically the output result would be in EDX, ECX, EBX, and EAX registers, right? And the return will be up to 48 characters in length. And the way we're supposed to do that, it's like EBCD, right? EBCD, ABCD, yeah. Cool. And we would also need to scroll the function from 2 to 4, right? So we will be needing to invoke that function with the number 2, 3, and 4, right? So I guess we could unsafe function. I want to redo that a little bit, so that would be entry. That thing would actually be get vendor name, right? Name equals to get vendor name, right? Yeah, get vendor name is supposed to return the string, and vendor name string, right? And let's see, the CPU brand. So it's supposed to be from extended list, right? From these, from that to that, right? So, okay, so for offset in 0 to 3, right? Let's see, let's take that, let's take that, let's maybe take that here, and it's like CPU brand name. The length of that should be 848. Offset this. The function is supposed to be that, right? But plus offset, I guess, right? Cool. And then yeah, we're not returning it here. Cool. So the order in which those pieces of the string are returned is A, B, C, D. Basically, it will be cool. So let's see, A, ECX and EDX. Something like that, right? Plus offset and CPU brand name. And let's just go ahead and print that. So CPU brand name, which is CPU brand name, get CPU brand, right? Let's see. Cargo run. Something is not working. Push string, plus offset. Let's see. Oh, yeah. OX, right? Yeah, so it works. AMD Ryzen 9. You know what? I think we should actually like trim matches, right? Something like 0 as char, and then into, right? Because the thing is, it would probably just end with a bunch of zeros, right? So if we do that and basically just print it as is, right, the result will actually end with 0. So I guess trim matches 0 as char into. Cool. Yeah, so basically this is exactly what we are looking for. So vendor name and CPU name, right? Cool. So vendor name is Authentic AMD and CPU name is Ryzen 9. Yeah, let's just go ahead and run that code here. Honestly, I really wonder what these guys are running. Cool. So looks like this is AMD as well, right? So Authentic AMD, CPU name is AMD EPIC 7R32. What kind of CPU is that? You can actually buy a used one for $450. So it's a 48 core, 90 thread available CPU, which is, you know, pretty dope. Not bad, not bad. Cool. Let's maybe try some others. So like Rust Online. Let's try that one. So okay, run. Okay, so Epic 7B13. That's different. AMD this. Oh, that one is fancy. $800. So 64 core, 2 and 2 gigahertz SP3 processor. Pretty good. Cool. What else? I think one of those were interesting. Let's see. Rust, Replit. I don't have an account here. JDoodle. Let's see what you guys have to say about my code. All right, let's see, JDoodle. So another Epic, but I think these guys actually have an Intel machine as well. So let me try to re-execute that command several times and see if we get, yes, Intel Xeon Platinum. And I think that one is kind of fancy. Let's see, like eBay. Well, you can buy used for $800, but I think CPU World benchmarks. I think that one is actually kind of expensive. Yeah, let's see. So it's 8259, right? Oh no, it's different. I don't know. But yeah, I mean, there you have it. So we have a very simple script that allows us to get the processor name from whatever vendor we are, from whatever. So there you have it, right? We have a very simple program that can look up the processor name from whatever sandbox we're running in. And I think this is pretty interesting, right? So I'll post that little snippet somewhere, and you can play around with that on different sandboxes and stuff. And I think that's all that I have for today's short video. And let me know if you have any questions, and see you, folks.